Okay, we are going to begin a unit on factoring, and this unit will be about 2 to 3 weeks long. It is going to involve a lot of knowing some math facts that will be helpful to you. You'll be able to do some of the work a little bit faster. However, if you don't know your math facts, multiplication facts as well, you always have access to a calculator and or Desmos to help you with that, and then I have some strategies for you as well. So it might just take you a little bit longer, but you can also do it. So the first thing with factoring is being able to factor out a GCF, or a greatest common factor. Common meaning same, factor meaning something that multiplies to be it. So let's take a look at the notes. So we're going to use the inverse of the distributive property to factor the greatest common factor out of a given polynomial. So we're familiar with the distributive property. So if we think of that in inverse, we're pulling out a factor. So if we're doing the inverse, then of course using the distributive property will be a way to check it. So your warm up or do now, I think your notes say warm up, and this is where you're going to put your answer for the warm up, which is equal to the following. This is just a review of multiplying powers. We have 4 squared times 4 to the negative third power. Remember, when you're multiplying powers that have the same base, in this case 4 is a base. It is not a coefficient, so you are not multiplying your 4s. When you multiply powers with the same base, you add the exponents. And in this case, you should have chosen answer C, because you would get 4 to the negative 1, and then you would move it to lose it. So it would be 1/4. And this little anticipatory set kind of gets us started with GCF. And you should be familiar with greatest common factor. What is the greatest common factor of those two terms? So look at the coefficients first, 4 and 8. What is the biggest number that multiplies to be 4? It's 4. And it happens to be a factor of 8. So therefore 4 is going to be part of our GCF. Oops, go back. So 4 is part of the GCF. Now, they both have A's in common. What is the largest amount of A's that I can take from both of them? I can only take one A from the second term, so then A is part of the GCF. And then they both have a B. But what is the most that I can take from both of them? I can only take one from the first term, so then B is going to be. So this is the GCF of these two terms. It is the greatest common factor of those two terms. So to factor polynomials using the distributive property, right, we're going to first find the GCF of all the terms of the polynomial. Find the greatest common factor, that one greatest common factor of all of the terms of the polynomial. So something that every single term has a factor of. You pull the GCF out, and you're going to write what's left over from each term in the parentheses. So really, we're more reviewing GCF, greatest common factor, and I am kind of teaching a short lesson inside of a bigger lesson, which is factoring a GCF. So we are talking about finding a GCF and factoring the GCF. That's part 2 and 3, pulling the GCF out and writing what's left over in parentheses. And we're going to be left with what looks like a distributive question. All right, so let's factor this polynomial, this binomial right here. We're going to first find the GCF. And now the way this demonstration is one way of doing it. All right, so if you were to factor each coefficient, kind of the way we did radical expressions, factor it all the way down to the prime, all the way down to the prime numbers. And again, this is one way. All right, what do they have in common? They both have a 2. They both have another 2. They both have 1a. And that's all they have in common. So then the GCF is the 2 2's and an a, which equals 4a. All right. Some of you may be able to look at those terms and think of the factors of 12 or the factors of 16, either one, and find the biggest one that will go into both of them. And in that case, it's 4. And for the variables, the smallest exponent on the variables, which is just a, is the GCF. So then if we were to factor 4a from both terms, you pull out the 4a, it comes over here outside, and in parentheses, what you're basically doing, which it didn't show here, you are dividing each term. Oops. I'm trying to put a 2 here. Dividing each term by 4a. 12 divided by 4 is 3. A squared divided by a is a. That's how I got the 3a. And then you have the 16a squared divided by 4a. 16 divided by 4 is 4. A squared, oops, this was not a squared. This was just a. Sorry, cross that off. A divided by a is no a, so that's how we got this 4. 4a, that's how we got the 3a, that's how we got that answer. So when you pull out the GCF, you're basically dividing each term by the GCF. And you put that in parentheses. And that was number 3 in your instructions if you look up at your instructions there. So 1, we found the GCF of all the terms. 2, you pull the GCF out. Here's the GCF. It starts the answer. And 3, you write what's left over from each term in parentheses. That's factoring out a GCF. Let's look at another example. And of course, you check your work by distributing. If you distribute back, you would get to the question. All right, so this one, we look at the coefficients first, 8 and 4. All right, the biggest number that I can divide both of those, I already know, is 4. I'm gonna put this 4 over here. All right, look at the variables. They both have an x. I can take an x from both terms, meaning I can divide both terms by 1x. Look at the y squareds. They both have a y squared, which means y squared is part of the GCF. And then z, they do not both have a z, so I cannot take a z from both. 4xy squared is the GCF. So we found the GCF of the terms. Now, number 2, you pull it out by putting it on the outside. And now I'm going to divide both of these terms by 4xy squared. 4xy squared. Both terms get divided. 8 divided by 4 is 2. X divided by x is no x. Y squared divided by y squared, there are no y's. Plus 4 divided by 4 is just 1. X divided by x, no x's. Y squared divided by y squared, no y squareds. And then we have the z. And that's our answer, 4xy squared times 2 plus z. And if you see, if we were to multiply this back, 4xy squared times 2 is 8xy squared. And then 4xy squared times z is 4xy squared z. So the distributing part is the check. What I just put a box around, is the answer. Let's look at another one together. All right, there's my two terms, negative a squared b minus a cubed. You notice we have no coefficients. All right, what's the most amount of a's I can take from both terms? The most I can take from this one is a squared. So a squared is part of the GCF. Can I take a b from both terms? No, I cannot. So a squared is the GCF. If I divide both of these by a squared, I would factor out the GCF. All right, negative divided by a positive is a negative. A squared divided by a squared, there are no a's, but there is a b. A negative divided by a positive is a negative. A cubed divided by a squared is 1a. And that's my answer. Oops, where'd that a go? And that's the answer. Again, if I were to distribute back, a squared times negative b is negative a squared b. And then a squared times negative a is negative a cubed. That's how you check it. Okay, let's look at another example. Oh, this one's going to do the prime factorization way. Again, you do not have to do it this way, but it's a very descriptive way. It's a solid way to do it. Now, let me go back. All right, so we factored everything down to the primes, even the variables. Now we're looking at what's in common to find the greatest common. So they both have a 5, and they both have an x. Therefore, the GCF is 5x. So then we take that out, pull the GCF out by dividing both terms. So this is what it didn't show you. 15x divided by 5x. And then plus 25x squared divided by 5x. Dividing both terms by the GCF. 15x divided by 5x is just 3. And 25x squared divided by 5x is 5x. And then notice the GCF is on the outside right there. All right, are you ready to practice 2 of these on your own? You have student example 2 and student example 3. Find the GCFs and factor them out.